Hey students, this is lesson 111. What we're going to learn today is what it means for something to be in direct variation or directly proportional. So to do that, I'm going to start with this problem right here. Develop and understand part A. And we're going to talk about Michaela. She delivered pamphlets explaining her town's new recycling program. And from doing this problem, we're going to learn what it means to be a direct variation. Okay, so the important information here is that on Saturday, she delivered 350 pamphlets. And on Sunday, she delivered even more, 150 pamphlets every hour. So to complete this table, what I'm going to do is, for Sunday is the day she just delivered 150 pamphlets an hour. So if we're talking about Sunday only, she started that day with 0 delivered on Sunday. And then every hour there's 150 more delivered, so I'm just going to keep adding 150. Or I can multiply the number of hours by 150. 4 times 150 is 600. 5 times 150 is 750. And so on. Okay, now the other part of the table I'm going to fill out is the total number of deliveries, and we use the variable t to represent that. The total number of deliveries includes the ones delivered on Saturday. So on Saturday there are 350. So when we start at 0 hours on Sunday, when we're talking about the total, we've already delivered 350. And then we're going to increase that total by 150. So I'm going to keep adding 150 to that. And I get these numbers. 800 plus 150 is 950, plus 150 is 1100, plus 150 is 1250. Okay, now we're going to answer a couple questions about this. And this is going to help us understand what it means to be a direct variation. So if we look at this table, as the number of hours Michaela worked doubled from 1 to 2, so she's working twice as many hours as what we're saying there. If we go from 1 hour to 2 hours, did the number of Sunday deliveries, so we're talking about this row here, also double? So what we're saying is 150 doubled equal to 300, and it is. So we're going to say yes, it is. As the number of hours work doubled from 2 to 4, did the number of Sunday deliveries also double? So if we go from 2 to 4, does the number of deliveries double there? I use a different color here. So we're going from 300 to 600. And yeah, if you double 300, you get 600. So that's a yes also. Okay, now for part B, as the number of hours works doubled from 1 to 2, did the total number of deliveries. So now we're talking about this column, total number of deliveries. So as we go from 1 to 2 again here, is 650 double 500? And we're going to have to say no, because double 500 would be 1,000. So now they're not doubling. And as we go from 2 to 4, so is 950 double 650? And the answer is no. Okay. Part C says, as the number of hours worked tripled from 1 to 3, did the number of Sunday deliveries also triple? So as we go from 1 to 3 now, let me erase a little bit of this. So now we're going from 1 to 3. So from here to here, does it triple when we're talking about this row, Sunday deliveries? So if we triple 150, do we get 450? And we do. Yes. And let's do another triple. So from 2 to 6, does it also triple? So at 2 hours on Sunday, we had 300. At 6 hours, we had 900. Is that triple? Yes, it is. As the number of hours worked tripled from 1 to 3, did the total number, so we're going to switch now. Now we're talking about total again, so this one. So as we go from 1 to 3, 3 is triple the number of hours as 1 hour. But is the number of total deliveries triple? So is 800 triple 500? 500 times 3 is definitely not 800, so it's no. And as we go from 2 to 6, does it triple in that row? And the answer is no. 650 times 3 is not 1,250. 650 times 3 is like 1,950. So the answer to both of those is no. All right, now look at the first two rows of your table and write an equation describing the relationship between the number of Sunday deliveries, S, and the number of hours worked. Well, we saw that we could just multiply to get the number of Sunday deliveries. We could just multiply our number of hours times 150. And in algebra, that's how we're going to say it. If you want to put a dot there just so you remember that's multiplication, that's fine for a while. But eventually, we're not going to put that dot in there anymore. And then we're also going to write one for write an equation for Sunday deliveries. And then if we look at the first and third rows of our table, the equation we would get there is the total number of deliveries. Now let's go back there and remember how that worked. Remember we started with 350 and then we added 150 for every hour. So if I multiply my 150 times my number of hours, say right here, 4 times 150, I would get 600, but I have to add on that original 350 that I delivered on Saturday. So my equation will look like this. You can still multiply 150 times H times the number of hours, but you have to also add 350 to get that. Okay. All right. All right, so now think about how the number of hours Michaela worked and the number of Sunday deliveries are related. When you multiply the value of one variable by a quantity, such as 2, 3, or 150, the value of the other variable is multiplied by the same quantity. That means that the number of pamphlets delivered is directly proportional to the number of hours worked. What we're saying there is, if we just look at Sunday deliveries, and if we take the number delivered divided by the hours, we always get the same ratio. I can pick another number. After 4 hours, we had 600 delivers, and if I find that ratio, 600 divided by 4 is also 150. All of these numbers are proportional to each other. If you remember that from 7th grade math, 150 over 1 is 300 over 2. The ratio is always equal. So they're proportional. And if the relationship in the two variables are directly proportional, then it's called a direct variation. All right? So the ratios have to all be equal. So if you divide the two numbers, I'll give you one more example. You can write this down, of a directly proportional relationship between two variables. And we'll use x and y. Those are the variables we're going to use a lot. So let's say we have x is 1 and y is 5. If x is 2, y would have to be 10 to be proportional. If x is 3, y would have to be 15. So if I divide y by x, 15 divided by 3, I get 5. 10 divided by 2, I get 5. 5 divided by 1, I get 5. Okay? In order for that to happen, we always have to start at 0, 0. When that's called a direct variation. Okay? What we're going to do is study situations and try and determine whether or not they're a direct variation. Think about going to a movie. The cost for one person to see a movie is $8.50. The cost for 2 people is $17. The cost for 3 people is $25.50. Does the relationship between the number of moviegoers and the cost represent a direct variation? Why? I want you to think about that and come to class with that answer. I may even have a spot for you on the web page for you to leave your answer for that. But basically, I'm asking you yes or no, and why is that if it is a direct variation? Okay. I think the rest of it we're going to do in class. And so take your notes and try and think about what a direct variation is, and I'll see you in class tomorrow.